Along with our conversation about mass and weight, um, means that we're going to have to tackle the idea, the concept of density. And for middle schoolers, the 8th graders that I teach, this is a topic that always causes some confusion. Let me give you an example. Let's say we have this huge, huge tree, right? And next to the huge tree, along with that tree, we have this, a quarter, kind of a big quarter. All right, so we have a quarter. And so my question to you is, which has more mass? Okay, or just basically which is heaviest. So the one that has more mass is going to be the tree, right? Obviously. My next question then is, which is more dense? Okay, and my answer to you would be the quarter. And I know that it's more dense because if, let's say we have a lake and we chop down the tree, then we toss that tree into the lake, that tree is going to float on top of the water. I know that because it's made of wood. Okay, so I'm going to toss it in there, and the tree ends up floating on top. As opposed to the quarter, if I toss the quarter into the lake, then the quarter is going to sink all the way to the bottom of that lake. There's my 25-cent piece. Okay, so density is kind of a comparison between how much mass something has and how much volume something has. And mass divided by volume, that is the formula for density, something to keep note of. And so let's say we have this tree again. Let's make our tree. And the whole idea of density is, what if we have just a section of that tree, a small piece of it, and that small piece of the tree is going to be in the shape of this cube that's 1 centimeter by 1 centimeter by 1 centimeter, 1 cubic centimeter. And so we have the tree material in the shape of that perfect cube. And then we have another shape, right? The exact same shape, 1 cubic centimeter, and instead it's made up of the material of our quarter, whatever a quarter is made of. So whatever that metal is, alright, that's going to be the size and shape of the cube, and our tree, of course, is made of wood, and that's the size and shape of the cube. So if the tree and if the quarter were the same volume, if it was the same shape, the same size, of course, which would have the most mass? Well, I hope you can just clearly say, oh yeah, the metal is going to obviously have more mass. So that's what density is about. It's taking two objects and comparing them in kind of a fair amount of volume if they had the same volume. So let's say, I don't know, we had some object and we're finding its density. We're going to take its mass, let's say it's 100 grams, and I don't know, its size takes up 25 centimeters cubed. And so we do the math, we reduce it, and it ends up being 4 grams per cubic centimeter. Alright, and that would be its density. If we have a different object and we want to compare, so we put the object on a scale, we get its mass, and let's say it's 100 grams again, but it takes up the space of only 20 centimeters cubed. Well, and it's a little bit hard to tell what's what here, so we reduce it and we say, okay, what if it was this size, and what if it was both objects were the exact same size, and it was that special 1 cubic centimeter. So we do the math on that, and 100 divided by 20 is going to end up with 5 grams for every cubic centimeter. So that's saying that if the object that we're talking about were in the shape of 1 cubic centimeter, it would equal 5 grams. And if this object was in the shape of that perfect 1 cubic centimeter, that object would weigh 4 grams. And so per cubic centimeter, this object would then be more dense. It would have more mass if the object was in this magical shape of 1 cubic centimeter. So remember, density is mass divided by volume, and it's different than just mass. If it was just mass, then the heavier thing wins. The heavier thing is going to have more mass. But it's mass compared with its volume. Alright, so you have to divide mass by its volume, and then you get density. So hope I didn't confuse you more. I'm hoping that it pushed away some of the clouds, and you have a better understanding of what density is.